Today first we will talk about molecular orbital theory. Earlier we talked about VVT. Today we are talking about MOT, molecular orbital theory. When an atom is converting into the molecule, then the theory molecular orbital is being constructed, is given by Mr. Robert Mulliken. What Robert Mulliken is saying: when an atomic orbital is overlapping and forming molecular orbital, the energy of atomic orbital and molecular orbital will be same. Second, the number of molecular orbital and atomic orbital will be same, but the size of atomic orbital will be differ. Whatever the molecular orbital is being formed is depending on the size of atomic orbital. Fourth, whatever the rule we are following to fulfill atomic orbital, the same rule Wundt, Pauli and about will be followed. The quantum number of electron of molecular orbital is also same in case of n, l and m, and s will be different. So this is all about molecular orbital theory. Okay, the most important one point is there that orbital is connected with the center of molecule, not with the one atom. All the orbitals are connected by the center of the molecule, not with the atom. So we are talking about molecular orbital theory. On the basis of molecular orbital theory, we are forming a line diagram of formation of molecule. Here I am talking about hydrogen. As we know that hydrogen is containing one electron. Hydrogen is containing one electron. We will write one hydrogen, one s1, one s1. This is atomic electronic configuration. Molecular electronic configuration sigma 1s2. Sigma 1s2. So when it is sigma 1s2, we will take atomic orbital in left side and right side. Atomic orbital of hydrogen left side, atomic orbital of hydrogen right side. It is 1s1, it is also 1s1. Clear? So one electron is there, that will come in sigma 1s, and that electron will also come here. That electron will also come here, where in sigma 1s, because we are following Wundt, Pauli's and Abbaus principle, and according to that principle, the bond will form by the pairing of this electron. So both the electron will come first in the lower orbit and then in the higher energy orbit. So now the number of sigma 1s, that is sigma 1s orbital, this is sigma antibonding 1s orbital. We need to know about bond order. Number of bonding electron present in molecule minus number of antibonding electron present in molecule by half or divided by 2. So number of bonding electron is 2. Number of antibonding, I am going for the next one. Bond order is equal to number of bonding electron is 2. Number of antibonding is 0 divided by 2, so it will be 1, and the molecule of hydrogen is formed with one bond. Clear? If I want to form H positive, which earlier I have formed, so here there will be no electron, it will be 0. As we read in VVT, that the defect of VVT, it is impossible to explain H2 positive ion. Now through molecular orbital theory we can understand H positive ion. Here it is H having one electron, that is 1s1, but here it is H positive, so there is no electron, so it is 1s0. So what will happen? Only one electron will come in sigma 1s bonding orbital. Only one electron will come in sigma 1s bonding orbital. That's why the bond order will be 2 minus 1. 2 minus 1. It is 1 minus 0. So 1 by 2 is equal to 0.5, not 2 minus 1. It is 1 minus 0. Clear? So the bond order for H2 positive ion, number of bonding electron will be 1, number of anti-bonding will be 0 divided by 2. So bond order is 0.5. Whenever the bond order is coming in complete digit, in that condition the atom is stable. But whenever it is coming in decimal or in negative, in that condition the atom is unstable. Okay, and whenever the bond order is coming 0, that molecule do not exist. That molecule do not exist. Whenever the bond order is coming complete figure, that is stable. If it is in decimal, that is unstable. But if it is 0, then there is no existence of that particular molecule. Now we are talking about helium. As we know that helium has 2 electrons, 1s2, 1s2. If we are combining, it is He2. So the electronic configuration of He2, sigma 1s bonding, sigma 1s anti-bonding. 2 will be here, 2 will be here. 1s2, 1s2, atomic orbital of helium, atomic orbital of helium. So 1 will go in sigma 1s, and this 1 electron from this side, 1 electron from this side, it will come in sigma 1s, they will form bonding orbital. Then the rest of the 2 will go to the upper energy level in sigma anti-bonding 2s, sigma anti-bonding 1s. So the number of bonding and anti-bonding electron both are 2 minus 2. The number of bonding and anti-bonding electron both are 2 minus 2. So the value will be 0, because 2 minus 2 is 0, 0 by 2 is equal to 0. So the existence of any inert gas in diatomic state is not possible. The existence of any inert gas in diatomic state, it is not possible. So this is helium, the hydrogen, then H2 positive, then helium. Now we will talk about nitrogen. What is happening in nitrogen, that we will talk about. Basically, the electronic configuration of nitrogen is N7. I can write twice because you can understand that here 2 times 1s2, 2s2, 2p3. If I am merging as a N2, it will be sigma 1s, sigma anti-bonding 1s, sigma 2s, sigma anti-bonding 2s, pi 2px is equal to pi 2py. They both will be together because of regenerated state, and then sigma 2pz. Only this much we need, that is why I am writing only this much. Now the arrangement of this is the energy level from where increasing energy we are showing. It is atomic orbital of nitrogen. It is also atomic orbital of nitrogen. As you are knowing, it is 1s2, 2s2, and here it is 2p3. I will show you the connection of 2p3. Here it is 2p3, it is 2s2, it is 1s2. As we started the upper layer, we must know that 2 electron in this atomic orbital, 2 electron in this atomic orbital, means this molecular orbital is completely filled. So 2 electron will go in sigma 1s bonding and 2 electron will go in sigma anti-bonding, 1s anti-bonding. Then again it is completed. So 2 electron will come in sigma 2s bonding and 2 electron will come in sigma 2s bonding. Now we have more 3 electron which we will fulfill in which p orbitals. So the connection of p orbital which we do is in such way. This I have to shift little more. This will be like this. This is 2 and then this is 1. Pi anti-bonding 2px, pi anti-bonding 2py, sigma anti-bonding 2pz. This is like that. Now see, the lines should not get any overlapping. It will connect from this to this and this, like this. They should not overlap each other. Now it is going to connect with this, then this one, then this one. On the same hand, it will come here, then here, then here. It will come here, then here, then here. It should not overlap each other. The line should not be overlapped by each other. Now we have 3 electrons and we have 3 orbitals. 3 this side, 3 that side. First this is the same orbitals. Now we can write in this way. One is pi to px bonding and other is pi to px anti-bonding. That was pi to px anti-bonding. These are pi to px anti-bonding and pi to px bonding. The lower level will be bonding orbital, the upper layer will be anti-bonding orbital. So there are 2 orbitals with the same energy level. One electron come this side, another will come this side, then pairing will take place. First you will fulfill this one, then you will do pairing. Now 2 more electron you have, that you have to go to the upper layer with higher energy. You will fill one and then you will do pairing. Till you have 2 orbitals are present. First you will fulfill single and then you will do pairing according to Hund's rule. That's why in bonding pi to px, bonding pi to py, first one electron, then the pairing will take place, the rest electron will go in sigma to pz. Now we have completed all 14 electrons. 2 plus 2 4 plus 2 6 plus 2 8, 8 to 10, 10 plus 4 14. We will count the bonding number of electrons and anti-bonding electron. This is bonding orbital 2, this is also bonding orbital 4, and these all are bonding orbital. So total number of bonding electron is 10 and anti-bonding electron is 2 plus 2, that is 4. That is 4. If we are going to divide it, definitely we will divide by 6 by 2. So the bond order of nitrogen will be 3. The bond order of nitrogen will be 3 and that's why it is N triple bond N. Okay, N triple bond N. So this is the molecular orbital diagram of nitrogen. Your homework is that you have to form molecular orbital of oxygen. Only these 2 are very important and that 3 are. You just make a proper molecular orbital diagram.